Hey guys, I am here at Space Camp again, and wanted to talk about how we interact with waves. Sometimes waves, like if they're mechanical waves, they give us a push or a pull, and we can feel those. Like if we're in the ocean, we can feel it moving. However, in electromagnetic waves, there's a lot of different things that the waves do. They can do things called reflection, refraction, transmission, and absorption. And so we're going to talk about that today. Reflection, I'm here seeing these interesting things. Reflection is, when waves bounce off of one thing from another. So one of the things to know about reflection is that the wave will come, it'll bounce off at the same angle that it comes in. So whatever angle it comes into the surface, it bounces off of the surface. Now, it does that as well for things that are not flat, all right? So like my shirt here. So light waves are coming in and bouncing off my shirt, but there's two different types of reflection. This is called regular reflection, when the surface is so smooth that all the waves come in and bounce off at the same angle. And this is called diffuse reflection, when things come in and they scatter once they bounce off. So my shirt, like this part of my shirt, is green because it is diffuse reflecting green light. And one of the ways you know that is as I go from over here, it's green. I go from over here, it's green. So that means that the light is scattering all the different directions. Whereas this light is going straight in and straight out. So you can see that it doesn't actually matter. So that if you were not standing right here, you would not see something. So there's some pretty cool little visuals you can get from this here at Space Camp. So a mirror is a regular reflection. All right, a mirror is a regular reflection, whereas a wall or a shirt or whatever is going to be considered diffuse reflection. So the second thing I want to talk about is transmission. So light can travel through things. So this is an example of transmission. This would be a transparent transmission, meaning that the light can travel straight through it. You can see it goes there, it comes straight out the other side. So that is transparent. Then the second one would be kind of translucent. So if we make this light a little bit fuzzy, all right, so you can see how it's not exactly the same as it was. All right, so that would be translucent. That's not exactly a great example of translucent, but if I had a piece of paper and I held it up here and you could kind of see the shadows on the other side of the piece of paper, that would be a good example of translucent. Clouds are a good example of translucent. And then the last one would be opaque. So if you see, we have this here, and then I do that, see how there's no light that's passing through this thing? That would make this thing opaque, all right? So no light passes through, that's opaque. So we have opaque, transparent, where all the light passes through, and then translucent is when some of the light passes through. Let's see. Can't find a good example of translucent. Anyways, so when light passes through, like this, this is called transmission. So currently, light is coming from these lights up there. They're coming and bouncing off of my head and going into the camera. Then when you're watching this video, your camera or your computer, whatever, is showing you an image of me, and the light is traveling from you through the air to your eyes. But no, so from your computer through the air to your eyes. So the air is allowing the light to pass through it. So that is called that's called transmission. Sorry, transmission. Now, the last one is refraction. Refraction is when light bends. All right, so when light travels through different materials, they can speed speed up or slow down. So light travels the fastest through air, and then it will speed up or it'll slow down when it comes through here, and then it will travel faster when it comes back through the air. So it goes fast, slow, fast. So if you have something that is bent, right, like this, you have something that is bent, what's happening is the light slows down. And when it slows down, this part of the wave slows down before this part of the wave. And so that ends up bending the light. So you have things like this, all right, will bend the light as it's coming in and come out the other side. Now, so this light's coming in here. This part of the wave is slowing down first, and you can actually see how the wave bends here, and then it comes out here on the other side. So that is called refraction. Now the light passing through here is transmission, all right? And this is a transparent material that allows the light to pass through. Now this can get pretty interesting when you have particular colors. So we learned yesterday that different colors are different wavelengths of light. So red is the longest wavelength, which means it's the lowest frequency, and purple is the highest wavelength, which means it is the lowest frequency. So this is a filter. All right, the filter is transparent to green, and it absorbs all of the other colors. So when something is translucent or opaque, they actually are absorbing colors. So we have so this is green, so you can see here, this green does not allow the red to pass through, it does not allow the blue to pass through, it does allow the green to pass through. It is absorbing the other colors. Whereas if I have this red filter, then the red does allow the red to pass through, does not allow the blue to pass through, and does not allow the green to pass through. And there's our yellow. Our yellow actually allows the red to pass through and some of the green to pass through and none of the blue. So with these colors, what happens is our eyes actually take these colors and they're different wavelengths of light that are being reflected or absorbed or transmitting through an object, and our eyes take that information and turn it, and whatever light hits our eyes, that color is the color that is that our brains interpret as a color. So our brains interpret the low wavelength as red, the low wavelength as purple, the long wavelength, which is the low frequency, as red. And so if your brain gets lots of colors all at once, like this light here, all right, so if your brain gets lots of colors at once, then what your brain actually says is, that's red, orange, yellow, green, blue, and you go about it. All right, so your brain's like, hey, that's all the colors. And your brain doesn't like to think that's all the colors, so what it does is it kind of like, it goes like, okay, that's white. It's just going to call it white. So this right here is white material. This white actually is reflecting all the wavelengths of light, whereas this red is reflecting all of the wavelengths of light that are red, and they're absorbing all the wavelengths that are not red. So this part of my shirt is reflecting all the wavelengths that are purple and absorbing all the wavelengths that are not purple. So black then is absorbing all of the colors. So black is the absence of light, whereas white is all of the colors combined to reaching your eyes through whatever material that you're looking at. So that's reflection, refraction, transmission, and absorption. Of course, I'll give you some more notes specifically to write down later, but I hope that makes sense.